Hello. In this video, we'll cover information that's found in Chapter 2, Module 1, building upon what we already learned about the synapse. By the end of this video, you should be able to explain what the reflex arc is, as well as differentiate between temporal and spatial summation so that you can complete a discussion assignment that goes along with this video. The reflex arc should look familiar to you. It's something that we've seen previously. It's the circuit that goes from the sensory neuron to the muscle response. So here we're going from our skin, and that peripheral process or dendrite is going to receive that information and send it into that sensory neuron. Notice here again how it's outside the spinal cord and that ganglion. And that information is going to continue on into the interneuron, which will then convey that information to the motor neuron. And that motor neuron can then take that information out to the muscle to have a reflex. And so this is called a spinal reflex, and it occurs without the brain processing that information. Now you'll see here that that interneuron also sends a signal up to the brain. But sometimes, like if we are about to step on a tack or have our hand over a hot fire, we want this reflex arc to work so that the time it goes from our skin and sends that signal out to our muscle is much quicker so we don't get hurt so badly. So Charles Sherrington used this reflex arc to study the transmission of that impulse along these processes, and from doing that he learned a few different things and ended up coining that term, the synapse, that we've talked about. So two of his important observations, and he really made three, but we're only going to discuss two as they're what's important for what we're going to be talking about in this video. So two important observations that he made about reflexes from that reflex arc was that one, reflexes are slower than conduction along an axon. So they knew at the time, it had been measured, that an action potential speed was in that system was 40 meters per second. Now remember, we said it could be anywhere from 1 meter per second to 100 meters per second. So in that sensory neuron, in that motor neuron, the action potential speed is 40 meters per second. However, when he measured the time for it, he was doing a paw pinch reflex. When he measured that time from pinching the dog's paw pad to when they had that reflex and pulled back that leg flexion, the reflex arc speed was 15 meters per second. So the action potential was traveling down the axon at 40 meters per second in both the sensory neuron and the motor neuron. However, the reflex arc speed from going to pinching the paw to pulling that leg back was 15 meters per second. So he said something was going on that wasn't just the action potential hopping from the end of that sensory neuron's axon terminals to the interneuron, and then again that interneuron axon terminals to the motor neuron. Something was slowing it down. So again, they knew how from the afferent neuron to the efferent output, they knew and could measure the length of those axons. They could also measure how fast that signal traveled in each of these individual axons, and they knew that was 40 meters per second. However, when you started here and ended here, the speed was 15 meters per second, suggesting that something was slowing down that action potential here. The second observation that he made was that several weak stimuli presented at slightly different times. So here's the dog's paw pad, 1, 2, 3 stimulations, or at slightly different locations, 1, 2, 3 at the same time, produced a stronger reflex than a single stimulus did. So again, here's the dog's paw pad. If he presented several weak stimuli at the same So again, here's the dog's paw pad. If he presented several weak stimuli in the same spot, but presented at different times, 1, 2, 3, that produced a stronger reflex than a single stimulus did. Or and we'll learn that that's called temporal summation. Or if he pinched the dog's paw pad in 1, 2, 3 separate locations, or 2 separate locations, that could produce a stronger reflex than a single stimulus did. And that we'll learn is spatial summation. So again, temporal summation is this idea that repeated stimuli can have a cumulative effect and can produce a nerve impulse when a single stimulus is too weak. So one stimulus, too weak, 1, 2, 3, repeated stimuli in the same spot can produce a nerve impulse. So again, this is with time, right? Time 1, time 2, time 3. And that's what we're seeing here. So one stimulus, not enough. Because remember, this is threshold. This little faint line here is threshold. Here we're at resting membrane potential. So one weak stimulus, not enough to get it to threshold, no action potential. A second weak stimulus, not enough to get it to threshold, no action potential. But here, 1, 2, 3 gets it to threshold, and we have an action potential. So here's 2 firings with a pause, and this is 3 firings in rapid succession. So 1, 2, not enough to get it to threshold, 1, 2, 3, firings in rapid succession, that's temporal summation, separated by time, produces an action potential. Now let's compare that with spatial summation. So spatial summation is synaptic input from several locations, can have a cumulative effect and trigger a nerve impulse. So separate locations, location A, B, and C. So if we stimulate A, we pinch A here, not enough to get it to threshold. So again, here's threshold, no action potential. We pinch point B, not enough to get it to threshold, no action potential. We pinch point C, not enough. But if we do 1, 2, and 3, or A, B, and C, all at the same time, so now it's at the same time but in different spaces for spatial summation, we get to threshold and we have an action potential. So A, B, and C firing simultaneously, so different locations firing simultaneously gives you spatial summation. So here's just a side-by-side comparison. So how you can tell whether it's, by looking at a graph like this, whether it might be temporal or spatial. Here, you can see they're all firing at the same time. Here you can see there's little jumps jumping up. Here's showing you one connection, 1, 2, 3 firing. Here's showing you, so this is time, temporal. Here's 1, 2, 3 places in space, so it's spatial summation.